So this question here is asking us to find the least residue solutions to this quadratic congruence. X squared plus 7x minus 12 is congruent with 3 modulo 21. Now there's something here that we need to take care of, is this modulus value, modulus 21. Now 21 is obviously not a prime number, but it's a product of two primes. So we know 21 is 7 times 3, and 7 and 3 obviously are prime factors. So we can't just go straight away trying to solve this modulus 21. We need to take this into account. So when we try and solve this, there could be up to 4 solutions. Whereas we solve this modulus 21 straight off, we're only going to find 2. So we'll be missing 2 more solutions, quite possibly. Okay, so the way to go about that is to try and solve this equation initially, modulus 7 and modulus 3. So let's go about that. So x squared plus 7x minus 12 is congruent with 3 mod 21. So let's just rewrite this for modulus 3. Okay, now as we're looking at quadratic congruence, we can change some of these values, modulus 3. So let's just go through that. So now we're left with x squared. So 7x, we can change this, modulus 3. So 4x is congruent with 7x modulus 3, and so is 1x. So we can change this to x. And minus 12 modulus 3 is congruent to 0. So this term here can completely disappear, as can this 3. So 0 is congruent to 3 modulus 3. So we can change this into this format. Okay, now we can just factor this, just as we would in a normal quadratic question. And that will give us this, x times x plus 1. So we know that either x is 0 or x plus 1 is 0. But it's not equal 0, it's congruent with 0. So there is many solutions. So the first one, I'm going to concentrate on this term. So it's a x is congruent with 0 mod 3. So therefore we can say our solutions for our x here, our x can equal 0 plus 3n. So that's our first one. And then our second one, we'll work on this one and say x plus 1 is congruent with 0 mod 3. And now let's find our x. So x is congruent with minus 1 mod 3. So bring the 1 to the other side. That's valid. And then minus 1, we want to get a positive integer. So we know that minus 1 is congruent with positive 2. So x is congruent with 2 mod 3. So therefore our x's on this one can be 2 plus 3n. Okay, so we need to note here that our n is an integer. Okay, so let's write these up on here. So we've got 0 plus 3n and 2 plus 3n. So these are our building blocks to find our 4 solutions. Okay, let's take this off the board and try and solve this now modulus 7. Okay, let's write it up. So x squared plus 7x minus 12 is congruent with 3 modulus 7. Let's build on this. Okay, well, x squared can stay, modulus 7. Now the 7x, that's also congruent to 0 modulus 7 because of this coefficient. So this term can disappear. Now this minus 12, we can bring this down to minus 5. And then that is congruent with 3 modulo 7. Okay, now let's just try and simplify this up even more. Now this minus 5 we can bring to the other side and add 5 to both sides. So therefore x squared is congruent with 8 modulo 7. So that's just added 5 to both sides. That's completely valid. Okay, so now what we want to do is try and take the square root of this. But the square root of this is not going to work. So we need to find a number that's congruent to 8 modulus 7. Now we know that 1 is congruent to 8 modulus 7 and it's got a square root, so we can do that. So x squared is congruent to 1 mod 7. So therefore we've now got two solutions, plus and minus 1 modulus 7. So x is congruent to, let's just put the positive 1 in for start. So therefore we've now got 1 plus 7n, and that can be another one of our building blocks. And now looking at the minus value, x is congruent to minus 1 mod 7. So minus 1 we know is congruent to 6 modulus 7. So therefore our solution here is 6 plus 7n. So that's our next two building blocks. So let's write that up here. 6 plus 7n. Okay, let's take this off the board and then we'll try and find how we're going to find our four solutions using these building blocks here. Okay, so now what I'm going to do is I'm going to arrange these solutions modulus 3 on this side, and I'm going to give them a label. So my A solution is 0 plus 3n, and my B solution I'm going to call 2 plus 3n. And then my C and my D will be these respectively, and I'm going to put these on this side. So I've got 1 plus 7n, and my D is 6 plus 7n. So now we're going to use something called the Chinese Remainder Theorem. Chinese Remainder Theorem. Okay, so what that involves us doing is doing a combination of either one of these in combination with either of one of these, and we solve it in a method I'm going to show you in a moment. So basically this one will have a solution with this one and this one, and this one will have a solution with this one and this one. We can't go with A and B and C and D. We have to combine the different modulus answers. So we've got the 3s and the 7s on separate. Okay, so the way to go about that is, first of all, I'm going to pick A and C. So for A and for C. And what we do is we take the first part of this building block here, so 0 plus 3, and instead of writing n, I'm going to change the variable to a k, because this variable is what we need to solve for. And then that's going to be congruent to 1, as I'm using C, and it's modulus 7. So now we need to try and find a value for k. That's our next stage. So 3k is congruent to 1 mod 7. And now we need a value for 1 that is congruent to 1 mod 7 that divides by 3, so we can solve for k. Well, if we keep adding 7 for this, we'll come across 8 and then 15. 15 is good for us. So 3k is congruent to 15 mod 7. So now we can see that k is 5. So k equals 5. So now this is going to give us our next stage of this, where we use this 0 plus 3. Instead of the n, I put 5 in brackets. Then I add my 7n, and that's my next stage. So my 1, I've solved using my congruence to find a k. So I don't put the 1 in, I put my k value in. So 0 plus 3 times 5 plus 7n. So this will give me my first solution. So 0 plus 3 times 5, so that's 15, plus 3 times 7n is 21n. And that's my first solution. So I'm going to write that on here. Okay, right, let's take this off the board and I'm going to combine A with D. Okay, A with D. So I start here with my 0 plus 3, as I did before. Change the n to the variable k. And my D is now 6 plus 7n. So I use, it's congruent with 6 modulus 7. Okay. So now I need to try and solve for k. Well, this one It's a little bit more friendly to us. 3k is congruent with 6 mod 7. I can go straight in and find my k. My k equals 2. So now using my a and my d, I've got 0 plus 3. And then my k I plug in here. And as it's going to be 6 plus 7n, the 6, I've now found a k to replace the 6, and it's plus 7n. Okay. So this is going to give me my second integer solution. So now 3 2s are 6, and 3 times 7n is 21n. So that's my second solution, 6 plus 21n. So let's write that over here. So you should always get 21n because we're trying to solve modulus 21. If you haven't got a 21 here, then you will have gone wrong somewhere. Okay, let's take this off the board, and this time we'll try B with these two. Okay, so now on to B and C. This time I've got 2 plus 3, and now my variable will be k instead of the n, and it's with C, so it's got to be congruent with 1 modulus 7. So that's using these values here, so my 1 and my 7. Okay, let's try and solve for k. So subtract 2 from both sides. 3k is congruent to minus 1 mod 7. So now I need a value of k that is congruent to minus 1 mod 7. So 3k is, so if we have a 6, we know that will divide by 3. So therefore 3k can be congruent to 6 mod 7. So divide both sides by 3. K equals 2. So now I use my B, plug that in our way we did before. 2 plus 3 times our k value, and then we add our 7n. And that's going to give me my third solution. So 2 plus 3 times 2, so that's 2 plus 6, and then 21n. And then that's going to give me 8 plus 21n. So that's my third solution. So let's write that in there. Okay, let's take this off the board, and let's try and find our fourth solution. So now B and D, so 2 plus 3, change the variable to k, and that's going to be congruent with my D, it's congruent to 6 mod 7. Okay, let's simplify this up. 3k is going to be congruent to 4 mod 7. And now we need a value here that we can divide by 3. That is also congruent to mod 7. So 4 plus 7 is 11, plus another 7 is 18. So 3k is congruent to 18 mod 7. So therefore my k is 6. So now I've got my k. Let's plug into the combination of my B and D. So 2 plus 3 times my k value. And then I just add on my 7n. And that's going to be my fourth solution. So 2 plus 3 times 6, that's going to give you 2 plus 18. 3 times 7, 21. So that's going to give you 20 plus 21n. So let's plug that in here. Okay, that's my 4 solutions. But the questions asked me to find the least residue solutions. So this here gives us our infinite solutions. What we're looking for is just the least residue solutions. That's just going to require us to have 4 answers. So our answers are x1 equals 15. That's our least residue value here. And 6, 8 and 20 for here. So now x2 will be 6. x3 equals 8. And x4 equals 20. And that is our answer. So if you plug those 4 values into this quadratic modulus 21, that should be valid solutions. I'll let you check that. Okay.